Okay, now that you finished your warm-up, we're going to go over just a few of the shapes. This is really just a refresher from what we've already been working on, which is surface area, total surface area, lateral area. So let's take a look at shape 1. It is a cylinder, and I asked you to identify the number and shape of the base or bases. So what is the shape of the cylinder's base? It is a circle. How many of them are there? There are 2, so that's what you should have on your card. Let's take a look at shape 2. This is what shape? A rectangular pyramid. What shape is the base? It's a rectangle. How many bases are there? There's just 1. So it tells us it's the difference between a pyramid and a prism. And these are all of the things that we've been talking about. The reason I'm reinforcing making sure you understand what shape the base is and how many bases there are is because that's important for the next thing we're studying, which is volume. Okay? So the volume formula is V equals big B times H. Now we've only been working with lowercase b, but this is big B times H. So what is big B? It is the area of the base, which again is why it's important to be able to recognize where the base is in that shape and how many of them there are. What is the H? Same as it's always been, it's the height. But when we're talking about volume, we can think of it as the layers inside the shape. So if I look at this shape as a 2D shape, it is a rectangle, right? But if I extend it upward to another base, now I have a 3D shape, and I can think of the inside of this shape as having many layers. I can dissect it and dissect it and dissect it into however many layers I want, and that is going to fill up the volume. So what are some things that we can think of in our everyday life that we might see? Maybe a fish tank is a rectangular prism. We're going to fill it up with water and fish and plants and little boats and all of that kind of thing. When we fill it up, we're talking about the volume of water that that container can hold. We're coming up on summer. What are we all thinking about? Being outside, jumping into a pool. That pool has a volume amount of water that we're going to fill it up to. If it's too low, we're not going to be able to swim in it. If it's too high, it overflows. Then we flooded our backyard, and our parents are very upset at that point. Think back to the beginning of the year in science when you were working with measuring liquid in the beakers. You probably didn't think of it this way, but you were measuring volume in that cylinder, in that beaker. You weren't using the volume formula. You were just filling up a cylinder to the point where your teacher asked you to. This way, we're actually going to go backwards, and we're going to start with the formula and determine how much volume a shape has. So what we're going to look at today is cylinders, cones, and spheres. So on your whiteboard, I actually want you to draw these 3 shapes, and I want you to label them. So draw the shape. Under the shape, I want you to label what each one of these are. So I'm going to give you just a few seconds to do that. And when you're done, I want you to hold your whiteboard up so I can see it, so that I know you're done and that you have everything labeled correctly. Okay, looks like we're all pretty much there. Good job, and thank you for labeling your shapes. So first thing we're going to look at is a cylinder. So again, if we go back to what I said before, the volume formula is V equals big B times H, which we have right here. What is the shape of the base of the cylinder? That's right, it's a circle. So I know, because we've been working on area formulas, that the area of a circle is pi r squared. So in my formula, I'm going to plug in pi r squared, which is my big B, and I'm going to multiply it times the height. Every time for every cylindrical shape. Okay? Now I want you to consider the cone, right? So we have the cylinder. You can think of like a soda can, a soup can, something like that, a similar shape, right? a cone is this shape, so like a ice cream cone or like the orange cones, the traffic cones, something like that. Now, if the circumference of the circle of my cone is the same as the circumference of my cylinder, and the height is the same, then I should be able to compare these two formulas fairly equally. And we're going to see how that works. So I want you to make a prediction. So on your whiteboard, under the cone, I want you to just make a prediction based off the formula of a cylinder, what you think the formula of a cone would be. So you could ask yourself this question first, and just looking at them, is the formula gonna be, is it gonna represent something that's less than the cylinder or more than the cylinder? So think about that as you're predicting what the formula might be. And as you're doing that, we're actually going to do a little bit of an experiment and see if we can see if your prediction visually matches up to what you have on paper. Okay, so I'm going to fill up the cone with water, and it's not going to be exact, and I can tell you it's not going to be exact because I guarantee some of that water is going to end up in this container below, and some of it actually kind of stays in the cone a little bit too. But we're going to come as close to it as we can. So if you take a look at that, I've filled up the cylinder using the water of the cone, which still isn't quite right, but I filled it up to about, what would you say? In a fraction form, it's about a third of that cylinder, right? So I can keep going. I haven't filled it up all the way yet. So let's try it again. Filling and spilling. Here we go. Kind of shake it around a little bit. Try to get as much out of that cone into the cylinder as I can. So I filled it up some more. What would you say I've done? Another third. So 1/3 plus 1/3 is 2/3. Way to work on your fractions, 8th graders. Okay. There's still space in that cylinder, so I know I can fill it up, I would say at least one more time. What do you think? Let's try it. Again, filling and spilling. I think some of it even got on the floor, but that's okay. Now, keep in mind, I still have some water left in the cone that I can't quite get out. But basically, it took 3 cones to fill up 1 cylinder, right? So, in your prediction on your formula, based off the prediction on the cylinder, what did you come up with? And take this into consideration. If you want to change your prediction, let's just talk about it. Knowing that it took 3 of these to fill up 1 of these, but this has less space than this, what do you think our formula needs to look like? Okay, some of you are showing me on your whiteboard, I see 3 times pi r squared times h. That's an interesting idea, but remember it took 3 to fill it up, but this is actually a smaller space. So we're actually correct. We're going to look at it as 1/3 of pi r squared h. So the formula for a cone is going to be 1/3 pi r squared times h. Because this cone is 1/3 the space of the cylinder. But do you see how knowing the formula for the cylinder is important? And that we're building from the formula of the cylinder to find the volume of a cone, right? We're going to take that idea and we're going to go one more level with it with the sphere. This time, instead of you predicting what the formula is for the sphere, I'm going to give you the formula for the sphere. Okay? It is 4/3 times pi times r cubed. Now you tell me, okay, if we compare those formulas, the formula for the cone was 1/3 is where it started. This starts 4/3. So the sphere and the cone, what does this formula tell me? That it would take 4 cones to fill up 1 sphere, right? Now, do you notice that I don't have a height here like I did in my other 2 formulas? Why would that be? What is the difference between the cylinder and the sphere? I have a definite height because I have 2 bases. Or I have, on the cone, I have a base and a point that I can draw from to determine the height. I can't do that on a sphere, but I can find the radius. See if I can pop this open. I can find the radius. So this is the diameter. The radius comes from the center point of the sphere out to the outer edge of that circle. And because it is 3-dimensional, I can cube it. So I can come out this way, I can come out this way, I can come out this way, an infinite number of ways. But the formula for it is to cube it because it is a 3-dimensional shape that doesn't have a definite height. It just has the layers. Okay? So, what we are doing today is you have a Canvas assignment out there on my Canvas page. You are going to do the formulas or do some problems with the formulas for a cylinder, cone, and sphere. You'll begin with the pretest. If you pass that pretest, you can go on to DIY 2. If you don't pass the pretest, you need to work on the practice sheet. What I need you to work on tonight is to make sure that you have gone through at least the first 2 levels, and we're going to work on level 3 tomorrow because level 3 is going to take all 3 of those formulas, and I'm going to actually have some cardboard shapes in here that we're going to use with DIY 3. So tonight, or today during the rest of this class period, and tonight for homework, DIY 1, DIY 2. Okay? All right, let's get started.